Tony, let's
Hello,
begin our conversation tonight with Tony and Anthony Cook. It sounds so formal,
Tony.
but Tony Cook. Um, Tony, you've been interested in telescopes and making observations. Well, it was pretty much your whole career, but when did you first get excited about telescopes?
Well, I got excited about the sky actually when I was 4 years old because my parents took a trip to Griffith Observatory. I went with my grandmother and parents, and my parents went into the planetarium show, but Grandma had to stay out with me because I was four. And it really got me wondering, what is it about stars you can know about when you're five that you can't know about when you're four? So sure enough, when I turned five, I got to go to the planetarium, and they were doing a show showing the winter sky, and they showed the Pleiades, which appropriately is in the picture here. And when I went outside, I recognized them right away. I said, "Oh, they showed that in the show." So ever since then, I got interested. I got a telescope shortly afterwards, one that I would probably say is inoperable now. It was a really bad one, but nevertheless, I could see the Pleiades through it, for instance, and I got interested in constellations and how to find things. And by third grade, I was giving talks about what I was seeing through my telescope and boring people already. So,
Uh, yeah, and then you were a museum guide at Griffith Observatory, and then a
that's right,
telescope demonstrator, and then eventually
astronomical observer.
astronomical observer.
Yeah,
So
yeah,
you do know a lot about telescopes and observing things. And right now, there is a comet that's observable. Is that the one in the picture we're seeing here?
that's right. It has a romantic, beautiful name. These things are named for their awesomeness. It's 2022 E3 ZTF.
Now, 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 why don't you tell us a little bit about it? I know you prepared some slides for it, and I'll just let you take it away for a while. And unless we have any questions, we won't interrupt you right away. But
Sure.
let's hear about
Well,
this comet.
okay. Well, basically, you may have seen, it's already hitting the news, a green comet to light up the sky, things like that. And that seems to be the main headline. It's kind of like supermoon. It's something annoying that the news always says whenever there's a bright comet in the sky. I don't think you'll see it looks green necessarily. Now, it's green in pictures, but basically, this is a comet that was discovered in 2022. In fact, this is where the name comes from. It's called C-2022. That just means a comet discovered in 2022. E3 tells you what part of the year it was found. So E is the fourth letter of the alphabet, and it's the fourth 2 week, fourth half of a month of the year. So the first half of January is A, second half is B, first half of February is C, then last half is D. So the first half of March is E. So that tells you it was found in the first half of March. And then the 3 simply means it was the third comet discovered in that part of the year. And this fairly recent naming convention is made because now there's automated surveys that are finding way far more comets than were found before, and older conventions just couldn't keep up with all the numbers that were being found. So this is a way that should hold us for a while. The ZTF, in fact, whenever you want to go to the slides, I actually have a picture of it. The ZTF has a relationship to Griffith Observatory, actually. It means the Zwicky Transit Facility. Fritz Zwicky, of course, was an astrophysicist who's famous for coming up with the idea of the supernova, along with a lot of other ideas. Because he was interested in supernovae, he was interested in getting high-quality, wide-angle pictures of the sky so he could start getting statistics on supernovae and galaxy clusters. So when Palomar Observatory was made, they added to its list of things to do a large Schmidt camera. And a Schmidt camera is just a camera that photographs in as high quality as possible a huge area of the sky. So for a long time, it was known as the Palomar 48 in Schmidt, and it opened about the same time the observatory did. it made the first survey of the entire northern hemisphere of the sky, and then similar telescopes in the southern hemisphere completed that survey. In the 1990s, I guess, it was turned into the Samuel Ocean Telescope because the film equipment had been taken out of it and instead electronic detectors put in. So in the big picture, of course, in the observatory is made from pictures made with this instrument. Now another set of electronic cameras have gone into it, which are kind of pushing the new technology of observational astronomy, and these are high-speed surveys of the entire sky. So Caltech has been doing a lot of work. A lot of it's actually classified as to how this telescope can really look at the entire sky in a couple nights and record every supernova, comet, asteroid, everything in it. And it's all automated. So basically, I've been told that the astronomer is given a program that tells them on their phone, here's the interesting things you might want to look at. Okay. So back in March, one of the interesting things that astronomers were told to have a look at was a comet. You see the names of Bryce Bolin and Frank Matchey, who apparently are Caltech astronomers who were the ones notified, but nevertheless, it was named after the ZTF telescope. Now, a lot of comets are found. This one wasn't, well, it was bright for its distance. I can't remember. It was found out, past Jupiter's orbit, but it was already relatively bright for something that far out. And what's been interesting in the last few weeks, it's developed a bright tail, and why don't we go to the? Oh, I'm sorry. Actually, I know. I'm supposed to go over to guacamole, right?
Exactly. Get yourself a snack and some guacamole.
All right. So I'm there now, and this is my first time. So if I do something wrong, please say so. All right. So what we're looking at is a picture of the comet's orbit. One of the first things found about this is that the orbit of this comet probably takes at least 50,000 years to complete. At least it did until this passage. It may be that this passage will just accelerate it just enough to throw it out of the solar system entirely. But in any case, it hasn't been near the Earth in thousands of, or tens of thousands of years. So what we're looking at here, the little oval, the bright oval near the center is the orbit of Neptune. And this thing goes out 28,000 astronomical units, which is why it takes so long to complete. Here's a picture of it taken back in October. These pictures are all by Michael Yeager. And Michael Yeager is a photographer who really just specializes in comets. There's a lot of people who take beautiful pictures, but Michael Yeager is the most dedicated I've seen just to comets. So these are images you'll be seeing that he got up until last night, actually. So this is what it looked like back in October when it was still quite distant from the sun. And already you can see, yes, it has a bright green coma and probably larger than the sun, actually, at that point. And then already a tail that's quite long. All right, so we'll go to how it's developed. Here we see it in January, the beginning of this month. It has a bright coma still green. In fact, it's kind of interesting. It's half white, half green. So apparently there's a lot of dust coming out on the sunward side. The blue tail is the ion tail of the comet. And ion tails kind of tell you which way the sun isn't. It's the charged particles from the molecules in the head of the comet that are electrically charged and streaming back with the solar wind. So they generally point away from the sun. But the dust tail is dusty particles that are ejected from the head of the comet and are left behind in the orbit. So they actually spread out and form a big sheet behind the comet's motion. And it's interesting that it's already so developed. Generally, comets that are dusty are the ones that are the most interesting to see with your eye. Now we'll go ahead to the 4th of January. And basically, it's just getting brighter. Now, around shortly after this, the moon began to interfere. But just in the last couple of nights, the moon is dimmed enough that people have been able to get it. This is actually last night. And we see the dust tail has grown. Also, the interesting thing is today, the comet is at its closest point to the sun. It's at its perihelion. So from here on out, it goes out away from the sun and not to return certainly before another 50,000 years and maybe never. It just depends on if like a planet that it passes through accelerates it ever slightly so much, it would be enough to eject it from the solar system. And right now that's uncertain. Now, visual observers have been watching how this brightens. Both electronic images and visual observations allow this light curve to be made. And we see that it's brightening. The smaller numbers mean that it's brighter on the left-hand side of this graph. And you see the date running along the bottom. So the comet is brightening. Remember that the faintest stars you see with your eye are roughly 6th magnitude. The brightest stars are either 0. Now, the very brightest star, Sirius, is minus 1.5. We won't talk about the sun. We're talking about nighttime stars here. But basically, the smaller the number, the brighter. Each magnitude is about 2.5 times brighter than the next one. And already tonight, it's about magnitude 6.5. So it's possible that somebody in a really, really dark sky could spot this with the unaided eye. It certainly is visible in binoculars. And it should get brighter than magnitude 5 in about 2 or 3 weeks. So now, that's not a spectacular view. But in binoculars, it might be very, very nice, and it certainly will make for great photographs. Just a few things coming up. This is what the comet's orbit looks like up close. So we're just seeing that part of a parabolic curve you see running through the solar system is the path of the comet, just the tiny part of it that's closest to the sun. And here we see where it is tonight. So it's kind of above the Earth, if you can imagine, and it's closest to the sun. So it's a little over an astronomical unit away from both of them. Now, comets can brighten even after their closest point to the sun because the heat that the nucleus is receiving from the sun takes time to percolate into the nucleus. So just as the hottest part of the day is not right at noon, it's usually a couple hours later because of that similar kind of heating delay in the atmosphere. Comets can actually become a little bit more active after they're closest to the sun. And the tail and all will continue to get longer and longer. An interesting thing may come up on around the 26th of January. This is when we'll be seeing the comet in the plane of its orbit. So instead of looking like a bright, broad, open fan, we'll be seeing all of the comet edge on, and that will make the tail look a lot more solid. That might be the best time for binocular viewing. And finally, late in February, or early in February, the comet goes through the plane of the Earth's orbit. And it will be closest to the Earth actually around the 26th, the date I mentioned before. I just put through these in partly because it's Halley's Comet, and I'll make one other mention of it here. But how a comet appears largely depends on where the Earth is with respect to the comet. And a lot of people remember the 1986, well, a lot of us older folk remember the 1986 appearance of Comet Halley being sort of disappointing compared to maybe what we were expecting. But actually the comet behaved the way it was supposed to. The reason it looked maybe a little disappointing is that when it was closest to the Earth in April 1986, it was also outside of the Earth's orbit, and it was highly tilted to our point of view. So the tail was very spread out. We were viewing it kind of head on, and this made the tail look very, very thin. One way of thinking of this is if you look at a table with a glass cover and it has a little bit of dust on it, you can't see the dust very well if you're looking at it from a high angle. But if you go down to the level of the table and look along the top of the table, the dust looks very thick and it's easy to see. You know, oh no, I didn't clean that. Well, a comet tail is a little bit like that. The more edge on you view it, the more substantial it looks. And here's the comet at the same distance from the sun, but the way it looked in 1910. And it's not the comet that was different. It was just the viewing angle was close to the comet's orbit. So it looked a lot thicker at that point. So anyway, we can look for it in the sky. It's currently just before dawn. It's moving out of the constellation Corona Borealis right now. So it's in the northeast part of the sky and fairly high up at dawn. And it's moving kind of it'll be moving between the Big Dipper and the Little Dipper, the North Star, in the next few weeks. So it should be easy to spot in binoculars. It's near bright stars that if you're interested in constellations, you probably already know. So it shouldn't be hard to find. Even if it's not visually spectacular, it should be great with photographs. So if you have a telephoto lens, it's in a part of the sky that doesn't trail very fast, so you can try exposures just on a fixed tripod up to like a minute or so with high ISO and your camera lens wide open, assuming you go out to a dark place, say like Joshua Tree or something like that, and assuming it's not raining, you could probably pretty easily get some nice pictures.
Yeah, and I want to encourage folks to send those pictures to us here at All Space Considered. Tweet at us, email us, send it to us on Facebook, wherever. We'd love to see your pictures of this comet. So, Tony, I wanted to ask you, why is it green? Why is the coma green colored?
Well, it's due to the molecules in the coma that were ice in the coma until the sun's heated it. They've broken free, and let's see, I guess these have carbon compounds and water compounds, but they produce a green emission line as they become ionized. As ultraviolet light from the sun strips electrons from the atoms of the gas, it can produce lines that are predominantly green. There's also a lot of ultraviolet and stuff your eye doesn't see.
Okay. Yeah. I know that diatomic carbon can have greens in it. And anyway, interesting. Super, super interesting. Have you seen the comet yet?
I haven't. I tried actually on New Year's. I set up my telescope and started taking pictures, but right then is when the high clouds began moving in. And I had so much reflected light just from the clouds, even though the air was very clear, I couldn't get anything. And within minutes, literally, the sky clouded over. I haven't had a clear view since. Even last night looked very beautiful out, but there was a lot of cirrus, actually. The moonlight wasn't a good combination.
Well, have you gotten any interesting photos to share with us since you left us? Anything?
Well,
show off?
I guess I sent in some just to show what I've been up to since I haven't been at Griffith. So I've been experimenting I've mentioned this before with lunar and planetary photography and deep sky objects and stuff. So these are just some images that I got with a 10-inch telescope in my backyard. And these were
stunning.
Well, thank you. These are made using video and averaging thousands of frames with software called Auto Stackert. And then what you end up with a uniformly fuzzy image, but it has all of these average of thousands and thousands of frames. So the software sharpens it based on the assumption that it's all evenly fuzzy, and you get an image that's just about as sharp as if your telescope was in space. It's really at the diffraction limit of the telescope. So, I know Chris Butler's out there. He probably has the names of these craters on the top of his head more than I do.
Maybe
I don't mean to put you on the spot. I know
I think Alphonsus is hiding in the mix, and Arzakel and a few of the others. But Alphonsus is the one that said
Theophilus, I think is the other one. Yeah,
that's right.
Yeah, and Racazel is actually interesting because the first director of Griffith Observatory, Dinsmore Alter, continued observing the moon at Mount Wilson Observatory after he retired from the observatory in 1958. And he, along with the Russian scientists, thought they saw a glow coming from that crater. And the Russian astronomer actually photographed a spectrum showing carbon absorption, or showing some kind of absorption lines. I don't think they were identified. And Alter thought he saw evidence of it in his pictures. Now, honestly, I don't see them. I've seen his negatives and stuff, and I don't see what he was talking about. But the thing is, this increased interest in this crater quite a bit, because a few years later, Jet Propulsion Laboratory was attempting to crash camera-equipped spacecraft into the moon. And once they started working on the last 3 of 9 tries, the last probe, Ranger 9, was targeted towards the areas that Dinsmore Alter had been studying to see if there was any evidence of eruptions. There are interesting discolorations around craters, but we don't think there's active volcanism, but there could be some kind of outgassing, I suppose.
So now you also managed to get a picture of one of my favorite galaxies. I know.
That's right. And here it is. Andromeda, or the M31 galaxy, our nearest big neighbor in space. I mean, after the Magellanic Clouds, of course. And then, of course, it has 2 satellite galaxies too, which I'm sorry. Here's one of them. This is, oh boy, is that M110 or M32? I'm not sure.
I think that's M32.
Okay, and then this is M110 down here, and it's the other satellite galaxy. And then of course,
I know it's NGC 205. I think.
Yeah. But the M numbers are just named for Charles Messier, who was a comet hunter in the 1700s, who kept finding fuzzy things that he got his hopes up that he had discovered a comet, because that was his only interest in life. But he was disappointed to find they were permanent parts of the nighttime sky and not comets. So to avoid constant disappointment, he made a catalog of what objects that he spotted and what other people spotted. The first list of 110 objects that are, actually still sort of cherished as some of the top things to look for as you start your career looking through the sky with a telescope if you're an amateur astronomer. Okay, so one of the first catalogs of deep objects. Well, here's the Pleiades, and this is one of the most recognizable things in the sky. At least I discovered as a 5-year-old. The Pleiades, of course, have been known ever since people had eyes, so nobody can really be said to have discovered it. But because of its hazy appearance in the telescope, Messier did include it in his catalog as number 45. And it's a bunch of fairly recently formed stars, hot blue young stars, that are passing by a cloud of dust and scattering light as they pass by. So 440 light years away. And then another recent image I got is this one. Now, I don't think these are award-winning pictures. In fact, this one has a serious problem because the camera was a little tilted, so the stars at the upper part are a little bit out of focus. But what I was trying to achieve with this is that I have a fairly cheap DSLR camera, an old Rebel 2 camera by Canon, and it's not particularly good for astrophotography. It has a terrible problem with recording red light. But what I've been doing is taking fairly short exposures and then stacking them together with Photoshop, and then removing light pollution by matching the color of the sky and removing that, and actually subtracting that color. And I've had a little bit of success in being able to get rid of the effects of light pollution. So, and here, this is the Hyades, the head of Taurus the Bull, with the bright orange star Aldebaran. So the Aldebaran is a foreground star. If I recall, it's like 80 light years away. But the Hyades are a star cluster that's over 200 light years away, if I remember right. Does that sound right, Chris?
I'm going to say the Hyades is out around 120, and Aldebaran's around 68. If I remember.
Okay, all right. So ballpark on my thing, but anyway, it's the face of Taurus the Bull, and but also a star cluster in the background there. And all right, so another region of the moon here, and I'm sorry, I don't recognize the name of the craters.
Oh my gosh. Yeah, the one in the upper left is one of my absolute favorites, Tony. That's
Is it
Gassendi.
Herodotus? Oh, Gassendi, okay.
Gassendi, the diamond ring. Love
and
that
you can
baby.
see rills crossing it.
Yep.
And so, this is a region that's kind of the edge of a mare on the bottom of the sea, and then you see some highland material. It's heavily battered, kind of sticking up through it.
Yeah, this also is a spot where they keep thinking they see those transient lunar phenomena, like Alphonsus and all that. Gassendi's another one of them.
Yeah.
So keep your eyes on it.
Yep. And then finally, Sinus Iridum, kind of a half-sunken crater, you might think of it. It's a crater that was formed and then mare material flooded over one edge of it. Just part of Mare Imbrium is the huge mare that's down below it, although mostly in darkness. One of the interesting things you see on the mare is that it looks like it's crumpled a little bit. Those are wrinkle ridges, I guess, from the mare material actually contracting and cracking up as it shrinks. Does that sound reasonable, Chris, or would you?
It's perfect.
Would you put it a different way? I mean,
no. You're exactly right. You captured something else that I really like. Just above the Bay of Rainbows, above the semicircle in the flat spot above it, there's a little crater that's Harpalus sitting out by itself. That's the one Chesley Bonestell in the 1950s used to paint pictures of people landing on. So yeah, just a little bit above it. Oh wow.
Oh yeah.
Okay. I know what that is.
Yeah. This one actually, I just happened to be shooting the moon one morning, like at 3 a.m, and the air got extremely steady, and I noticed that the libration or tilt of the moon was just right. That Mare Oriental was visible, and that's on the top in this view. If you saw it like at midnight with the full moon, it would be on the left-hand side. That's the east side of the moon in our sky, and therefore it's called the Eastern Sea. Although, if you were an astronaut on the surface, that would be on the west side of the Earth-facing side. But anyway, it's familiar. I should have probably put in the famous lunar orbiter picture, but there's a picture from lunar orbiter which got the first really clear view looking perpendicular at this object, and it's a huge basin of rings. I mean, it looks like a bunch of bullseye with a dark spot in the middle. So it's a impact basin. It's where an asteroid landed, and then it fractured the surface in all these big circular mountain ranges that spread about 1,000 miles. Well, maybe not 1,000, but several hundred miles from edge to edge.
That's a gorgeous shot, Tony. Well, that's beautifully shown. Really is.
Thank you. And then the one that I'm using as my screensaver in the background. So you see the Apennine Mountains below, and what did we decide that was? Aristarchus, I guess, the big deep crater with the jagged shadow cutting through it.
Yeah, it's not Aristarchus. I'm trying to remember. It's one of the ones that sounds like that, like Aristolus or Eratosthenes is in that area. I don't.
Eratosthenes, yeah.
Yeah. Well, but it's a really beautiful view of the mountains. Look at that. That's gorgeous. And we landed there, which is cool. Right?
Yeah, we can see. This is Mount Hadley, as I recall. Oh, this thing isn't. No, it's not. I'm not able to make the pen do what I wanted to. All right. Well, we'll go on. Yeah, here's Clavius.
All right.
This is if you saw the movie 2001: A Space Odyssey, it's where the big city was in the movie. The one connection with Griffith Observatory is that the crater that's on the bottom rim of Clavius is Russell Porter. And Porter was, of course, the designer of Griffith Observatory.
Yeah.
He was mainly honored, well, for a couple of reasons. He he did the cutaway drawings of the 200-inch Palomar telescope, which he was intimately involved with for from 1928 until he died in 1948. And he did the concept, or not the concepts, but he illustrated from the blueprints cutaway drawings so people could, marvel at the technology that was being designed and just even get a handle on it because it was so complex. But he also, in Scientific American, had made sketches of the moon through the 60-inch telescope. And this inspired a lot of amateurs to return to viewing the moon. People didn't seem too interested in it before, for a long time before. And so he revived interest in, amateur telescope viewing of the moon. And as a result, the International Astronomical Union named the crater for him on his death in 1948.
Wow.
Yeah,
I didn't know that.
Very cool.
And then finally, here we have, let's see, Mare Nubium, I would recall, right? Or is this, yeah.
Yeah, that's
I should know.
Humorum.
I mean,
That's that. It's right next door. That's Humorum with Cassandi again, right at the top.
all right. Okay, this is probably a mosaic made from that same set of pictures that I did.
Yeah.
So anyway, one thing I fear about these beautiful resolution sort of moon images is that it's going to seem very, very out of date in about like a year or two as we start to see more and more spacecraft going there. They're going to put all of the stuff to shame. So I'm glad to have learned how to do it while it was still
Yeah,
that's great.
This is a picture of Saturn last year, or actually in 2022. But it's the best I've done so far with it. But you can see, the Cassini division. If you look carefully, you can see the D ring, which is inside the bright, broad A ring. And you can see, so it's faintly visible around. So, but of course, Cassini did better than that. So,
Wow.
Anyway, so that's some things I've been puttering around with. Besides remastering my classical CD or LP collection that I started in high school into CDs. So I'm making it from an antique thing to something that now is considered state of the art into the already passé CD form.
Although some people are now collecting CDs again, they'll be hot before you know it. Tony.
Yeah, and they're still making CDs. We gave up LPs so that nobody would ever have to deal with them again, and suddenly they're popular again. I really don't understand it, and they're way overpriced for what you get. But this isn't an audio show, so I'll shut up.
No, but I enjoy audio as well. But thank you for sharing what you've been up to, Tony. We've all been curious to find, to get back in touch with you, and thank you for sharing all the observing tips for the comet. I hope some folks send us in pictures. And those were just amazing images of the moon. Folks were just in the YouTube chat, were blown away by these pictures.
Oh, thank you.
Absolutely blown away. So we'll have to check in with you again when we start doing the show in person. You'll have to come say hello to us, of course. And folks, we don't know quite when that's going to be, but let's all give Tony a round of applause here. Thank you for visiting us again, Tony. Much
you.
Appreciated.
Good to see
Very
you.
welcome.